In this lesson, we will learn real life graphs. So you can put the distance you traveled according to time in a graph. So the following graph, whatever you're seeing, represent the distance time graph, where the y-axis you are mentioning the distance, x-axis you are mentioning the time. So the line represent according to time how much distance you traveled. Okay, so the speed is the difference, the distance you travel, the change in distance over the change in time is the speed. So here the gradient, that is change in y over change in x, that is the distance they are measuring it in meters and the time in second. Therefore the change in meters over change in time is the speed. That is the answer will be in meter per seconds. That is the speed you are traveling it. So for example, in this graph, if you take 2 points, I mean, in order to find the gradient, you need to get 2 points and you need to draw a triangle. So if you get the point 10, 20 and 20, 40 by looking at those points, then you can see the change in y between those 2 points is 20. The change in x is 10. Therefore, the speed is 2 meter per second. So the gradient of a distance time graph represents speed. So what is displacement time graphs? That is also the distance, but the point is you are starting it from a particular location. That is the only difference. So the point 0, 0, so this graph saying at 8 o'clock you are leaving it from home. That is the point. So then you are going away from home. Then at the end at 1 o'clock you are returning back to home. The x-axis represent the miles away, but from home. From home, what miles away? That means you are coming back to your house. So in this graph, the sections A, I mean there are sections A, B, C, D and E. So the A and C show the traveling away from home. The B and D showing you are having some rest. The E represents you are returning back home, because from x-axis you are going away. From your home you are going away. So A you are going away, then B you are resting it, then you are going away, then they are resting it, then you are returning back home. At 1 o'clock you reach home. Okay, that's the graph is showing. So they can give you this graph and then they can ask you number of questions. So here at this point, you know, at 8 o'clock you are leaving at a particular location. Say example, you are leaving from home at 8 o'clock, then you are going away. You are going away, then 9 o'clock you are starting to rest. Okay, 9 to 9:30 you are resting it, then you are going away because you are going away from x-axis. So you are going away at 11 o'clock, you are reaching around 8 miles. Then you are resting. You are resting it from 11 to 12 o'clock, you are resting it. Then you are returning back home and you are reaching home at 1 o'clock. That's what this graph is showing. So what they will be asking, oh, what is the speed in section A? Because you can find the y change and you can find the x change. That is the speed. That is the change in y over change in x. So during A, the change, that is the gradient. So the change in meters is you are giving away 3 miles. You are going away within 1 hour. From 8 to 9 you are going around 3 miles. So the speed is 3 miles per hour. In 1 hour, the first hour you have traveled 3 miles. So that is the speed. So in B you are resting it. That's what saying, because you are not going away. I mean, this is parallel to x-axis. So therefore you are not going away. The same distance you are there, but you are resting it. The time is going, but you are not going away. So that's means you are resting it. Then you stop for 30 minutes. Then you are traveling from 9:30 you are traveling it again and you are traveling up to 8 miles. Then you are resting it. When with these graphs, they may ask you a number of questions. So question is, what is the average speed between 8 and 11? So 8 and 11, you have traveled 8 miles away. I mean, currently you are, at 11 o'clock, you are 8 miles away from your home. So what is the average speed? Average speed is the speed changing it, because the A and C, they are having different gradients. So that means speed changing it, but you can only find the average speed. So how do you find the average speed? The total change in y direction over total change in x direction. So at 11 o'clock you have traveled 8 miles. That is the y direction. And how much time you took? 3 hours. 8 o'clock to 11 o'clock. Therefore the speed, average speed is 2 and 2 over 3 miles per hour. It doesn't mean you travel 2 and 2 over 3 miles per hour every minute, but average you have traveled at this speed. So what is the total distance traveled? So he is starting at 8 o'clock, then he is moving away up to 8 miles, then you are returning home. That means he has to travel another 8 miles back home. So how much miles he has traveled? 8 plus 8, 16 miles he has traveled. So what is the speed in section E? The section A, again the gradient is the speed, but this is a negative gradient. So the y change is in the negative angle. So the change is minus 8 over 1. Within 1 hour he is returning it from D, from 8 miles away. 1 hour ago he was in 8 miles away. Within 1 hour he reached home. So in 1 hour he is traveling 8 miles backward. Therefore the gradient is minus 8. So that means he is returning back. Therefore he has to travel at 8 miles per hour.